Hey everyone, so we are looking at vectors and how they can be applied. This is mainly going to be a physics lesson, but we're looking at how vectors that we've been talking about can be applied in the physics scenario. So for the first scenario we're looking at, this is the first of the two, here's projectile motion, meaning objects moving through the air. So let's imagine we have something being launched through the air. We are often given the initial velocity, so the velocity that the object's being launched. So we're going to call this v sub 0, the initial at time 0. So there's a lot we could talk about. There's like a whole entire unit within physics about projectile motion. But here, let's just look at how we can take the initial velocity and write it in terms of the horizontal and vertical components. So we have learned that if this is the magnitude of a vector, that we can break this into the horizontal component and the vertical component. Okay? So we have an angle. Again, we're often be told that, the angle that the object's being launched at. Here, our horizontal component will be the magnitude of the velocity, of the initial velocity, multiplied by cosine of our angle. And notation-wise, we're going to use here v sub 0 of the x component, x being horizontal. And then for our vertical component, we have the magnitude of the initial velocity multiplied by sine of theta. And this, for notation-wise, we write as v sub 0 for our y component. Okay? So a couple of things just to share this with you. You learn in physics that when something is launched, the horizontal velocity, it is constant throughout the entire motion. So the horizontal velocity at the beginning is the same velocity right before it lands. It's the same velocity at the highest most point. Whereas the vertical component of the velocity, that changes with respect to gravity. Gravity affects the velocity at a certain point, and even at the topmost point, the vertical velocity is 0 at the topmost point. Okay, so there are equations that we have, but let's look at an equation just to, again, talk about these two components. So a projectile is launched from a cannon with an initial velocity of 65 meters per second, so there's our v sub 0, at an angle of 37 degrees with the horizontal. Find the component form of the initial velocity. So understanding what we have, the two components, v sub 0 times cosine, v sub 0 times sine, we have our initial velocity, we have our angle measure, so our components will be v sub 0, our x component, will be 65 times cosine of 37, which is approximately, well, you can figure it out yourself. And then for our vertical component, it will be the initial velocity, 65, times the sine of 37. Again, you could approximate that what that roughly is. So this is meters per second, this is meters per second. So the whole way through the motion, as the projectile is moving, the horizontal velocity is constant. Okay, I'm going to make a little note here of that. So the horizontal velocity is constant throughout the motion. Whereas the y component of the velocity, this is affected by the acceleration, or by the acceleration due to gravity. Okay, and there are equations that we have in physics, but again, this is just a little taste of the very beginning of a physics problem, how we can apply vectors to it. Okay, so now let's try this whole idea of writing the components with another scenario. If I can turn the page, here we go. So a box is being pushed up a 10-degree incline with 5.2 pounds of force. Write the component form of the force. So having a visual is always good. So we have our incline, okay, at 10 degrees. Good. So we have this box on the incline, and then we are pushing the box with 5.2 pounds of force. Now, we could get into friction and how friction affects things. There's a lot we could really talk about that we're not going to here. This is just the basics. So if this is, we consider our magnitude, our force magnitude, okay, the components would be, so our x component would be the magnitude times cosine of the angle measure. That is our x component of the force. And then the force for the y component, again, 5.2 times sine of 10 degrees. But I want to remind you, if you are taking a physics course right now and you're looking at force on an incline, there is more to this. You look at the weight of the object, you look at friction, you look at normal forces, but this is just the taste. We broke this down looking at the two forces, okay? So let's try one more example. So imagine that we have a boat. In this boat, it's in water, obviously. This boat is being pulled with ropes on both sides of the shore. One side is pulling the boat at 40 newtons at a 40-degree angle with respect to the heading here. And then the other side, someone's pulling at a force of 30 newtons at 37 degrees. So we want to find the resultant. That's the idea. We want to find the resultant of these two forces. Again, sum with vectors is resultant. So how do we do this? This is going to take some time to talk about. So the first thing is we can write force 1, the first force, as the magnitude multiplied by cosine of the angle measure. And then the other component would be the magnitude multiplied by sine of your angle measure. That is the component form for force 1. And then for force 2, it would be what? Well, it would be 30 cosine of 37, comma 30 sine of 37. And we're going to leave these as it is because we prefer exact values rather than approximates. Approximates get us further away from what's actually happening. Now I want to say here, before moving on, the horizontal components, because our boat's going to be going this way, our horizontal components both are positive. But our vertical components, because one is pulling, I guess you'd say, towards this side, and the other's pulling towards this side, one of these vertical forces will have to be considered negative because they're going in opposite directions. So we're going to throw a negative right here on this 30. Again, because they're going in opposite directions. Just know that. So now we want to calculate the sum. So if I want to find the sum of force 1 plus force 2, we have learned that that's adding the components. So we add our x component with our x component. Okay, so that's 40 cosine of 45 plus 30 cosine of 37. All right, and then we are going to add our y components. So we would have 40 sine of 45 minus 30 sine of 37. Okay. Now, I'm just going to placing this into the calculator. We get to f of our resultant vector will be placing the x component in. We get approximately 52.2433 newtons, and then our vertical component ends up being 10.2298 newtons of force. All right, so that is the resultant. In terms of finding the sum, this is the vector the movement of our boat after the two pulls. Now, what is the actual magnitude of the force? So thinking about this, so we know how to find magnitude of the resultant. That's related to Pythagorean theorem, so we 52.2433 squared plus 10.2298 squared, and that gives us approximately 53.2354. You can check me on that. And that is the resultant force. That's the force that the boat ends up going in. And then direction angle. Okay, so the direction angle, we can say, well, that's where we take the component. This, so let's see, how do I want to do this? We know that, well, force of the resultant times cosine of theta, and force of the resultant times sine theta. Okay, that would mean that we can set this equal to this. So 52.2433 equals 53.2354 cosine of theta. Okay, so dividing, we get 0.9814 equals cosine of theta. Arc cosine of 0.9814 is approximately theta, and we find that we get an angle measure of 11.0788 degrees. Okay, now this, like summarizing what we have now, our boat has a resultant force of 53.2354 newtons of force at 11.0788 degrees to the horizontal. Okay, so this, if you're not familiar with newtons, it comes back to it's a unit that really has mass, and it has meters and seconds, and has a couple other things, and it's a unit within physics and represents force. Okay. Previous example, I believe we saw pounds. Pounds is another type of force, but another type of unit for force. But here, we added two vectors. We found the magnitude, and with the magnitude, we found the direction angle. Okay. So just a little taste of how vectors are utilized in physics. Looking at component forms, and with here we added two vectors, and yes. So good luck practicing this. Really, you're just applying what you've already learned, and I'll see you in the next video where we talk about work.